Today we're covering how to build a fare alert system with rotating proxies in 2026. Tracking airfare prices manually is a losing game. Fares change thousands of times per day across hundreds of routes, and by the time you spot a deal, it may already be gone. A fare alert system powered by rotating proxies solves this by continuously monitoring prices across airlines and OTAs, then notifying you the instant a fare drops below your target threshold. Google Flights, Hopper, and Skyscanner all offer fare alerts, but they come with significant limitations. Update frequency is typically measured in hours, not minutes. Coverage is restricted to routes and dates the platform chooses to monitor. And you have zero control over the alert threshold. You get notified when the platform decides a fare is low, not when it hits your specific target price. Building your own system gives you granular control over every parameter: which routes to monitor, how often to check, what price triggers an alert, and how you receive notifications. The challenge is doing this at scale without getting blocked, which is where rotating proxies become essential. A fare alert system has 5 core components that work together in a continuous loop. The first is a route configuration database, your list of monitored routes. Each entry includes the origin airport, destination airport, travel dates or flexible date ranges, cabin class, and the target price that triggers an alert. Store this in SQLite for personal use or Postgres for multi-user deployments, and include fields for last check timestamp, current lowest fare, and historical price data so you can track trends over time. The scraping engine queries airline websites and OTAs for each route in your database. It sends search requests, parses the fare results, and returns structured price data. For travel sites, this typically means using headless browsers like Playwright or Puppeteer, since most airline sites render results via JavaScript. The proxy rotation layer sits between your scraping engine and the target websites. It manages a pool of IP addresses, rotates them according to configurable rules, and handles failures by retrying with different IPs. This is the most critical component for sustained operation. Without proper rotation, your system will be blocked within hours. The price analysis module compares current fares against your target thresholds, calculates price trends, rising, falling, stable, and identifies anomalies like airfares or fuel surcharge changes. It also handles currency normalization if you are monitoring fares across different regional airline sites. When a fare meets your alert criteria, the notification pipeline delivers the alert through your preferred channels: email, SMS, Slack, Telegram, or push notifications. The pipeline should include deduplication logic so you do not get spammed with the same alert every time the system checks a route. Travel sites are among the most aggressive at detecting and blocking scrapers. Airlines and OTAs invest heavily in bot detection because scrapers generate enormous query volumes without converting to bookings, which costs them money in GDS query fees. Your rotation strategy needs to account for this. With fare alerts which for airline websites rotate IPs after every 3 to 5 requests to the same domain. For OTAs like Expedia or Booking.com, you can sometimes stretch to 8-10 requests per IP before rotating, as they tend to have slightly higher thresholds. Never reuse an IP on the same domain within a 15-minute window. Airlines display different prices based on the user's location. A flight from New York to London may show different fares when searched from a US IP versus a UK IP versus an Indian IP. Use this to your advantage by targeting proxies in the point-of-sale country where fares tend to be lowest for your specific route. In general, fares are cheapest when searched from the departure country, but this is not always the case. Some travel sites track sessions across multiple page loads. When you search for a flight, select a fare, and proceed to booking, the site expects all those requests to come from the same IP. For fare monitoring, you typically only need the search results page, so sticky sessions are less critical. However, if you need to drill into fare details or check baggage fees, use sticky sessions that maintain the same IP for the duration of a single search workflow. For most fare alert systems, residential rotating proxies offer the best balance of cost and reliability. Reserve ISP proxies for your highest priority routes where you need guaranteed data collection. And use mobile proxies only for sites like Southwest or Ryanair that have exceptionally aggressive anti-bot measures. Most airline sites require JavaScript execution to render search results. Configure your headless browser to mimic a real user. Set a realistic viewport size, 1920 by 1080, enable WebGL, use a common user agent string, and set the language and time zone headers to match your proxy's geographic location. Disable automation flags that sites use to detect headless browsers. Minimize the number of requests per route check by structuring your queries efficiently. Instead of searching one date at a time, use flexible date search features when available. Many OTAs let you search a date range and return the cheapest fare for each day. This gives you 30 data points from a single request instead of 30 separate searches. Proxy rotation. You need rate limiting to avoid overwhelming any single target site. Implement per domain rate limits that cap requests at a sustainable level. For airline direct sites, 2-4 requests per minute per domain is a safe starting point. For larger OTAs, you can push to 8-12 requests per minute. These are per IP limits. With rotation, your total throughput scales with your proxy pool size. Fare searches fail for many reasons: captchas, rate limiting, site downtime, JavaScript rendering errors, or proxy failures. Implement a retry strategy that rotates to a new IP on each retry with exponential backoff between attempts. After 3 consecutive failures on the same route, flag it for manual review rather than continuing to retry and waste proxy bandwidth. Thus far, every fare observation with full context: route, airline departure and return dates, cabin class, fare class code if available, total price, currency, search timestamp, and the proxy location used. This granular data enables powerful analysis. You can identify patterns like fares being cheaper when searched from certain countries or at certain times of day. Simple absolute thresholds. Alert me when NYC low-end drops below $400. Work for well-known routes where you have a sense of typical pricing. For less familiar routes, use relative thresholds instead. Alert when the fare drops more than 20% below the 7-day average. Relative thresholds adapt automatically to each route's pricing dynamics without requiring you to research typical fares first. Beyond simple threshold alerts, track price trends to predict future changes. If a fare has been steadily declining for 3 days, it may continue dropping, or it may be about to spike as cheap seats sell out. Display trend data alongside alerts so you can make informed booking decisions. Overlay and support multiple notification channels and let users choose their preference. Email is reliable but slow. SMS gets attention but costs money at scale. Telegram and Slack bots are free and near instant. Push notifications via companion app provide the best mobile experience but require more development effort. Obor, a useful fare alert includes more than just the price dropped. Include the current price, the price change in absolute and percentage terms, the target threshold, a 7-day price trend for email alerts, the direct booking link, and a comparison of prices across airlines for the same route. The goal is to give the recipient enough information to decide whether to book without needing to do additional research. If a fare oscillates around your threshold, you could get dozens of alerts per day. Implement the duplication that suppresses repeat alerts for the same route within a configurable window, for example, 4 hours. Also implement a daily digest mode as an alternative to real-time alerts for users monitoring many routes who do not want constant notifications. A personal fare alert system monitoring 20-50 routes can run on a single server with a small proxy pool. As you scale to hundreds or thousands of routes, several architectural changes become necessary. Distribute scraping across multiple workers using a job queue like Redis or RabbitMQ. Each worker pulls route checks from the queue, executes them through the proxy layer, and writes results back to the database, letting you scale horizontally by adding workers. Implement priority-based scheduling, since not all routes need the same check frequency. Routes with upcoming travel dates or volatile pricing should be checked more often than routes with travel dates months away. Using a priority queue that dynamically adjusts check frequency based on travel date proximity and recent price volatility. Optimize proxy usage by batching requests to the same domain and rotating IPs at the batch level rather than per request, which reduces proxy consumption while maintaining detection resistance. The fare alert system needs its own monitoring layer. Track key metrics like successful scrape rate should be above 90%, average response time per domain, proxy failure rate, alert delivery success rate, and data freshness, time since last successful check for each route. Set up alerts on these metrics so you know when your system is degrading before it stops collecting data entirely. For a personal system monitoring 50 to 100 routes with hourly checks, a residential proxy plan with 5 to 10 GB of monthly bandwidth is sufficient, translating to roughly 500 to 1,000 rotating IPs. For larger deployments monitoring thousands of routes, you will need 50 plus GB of bandwidth and access to tens of thousands of IPs to maintain sustainable rotation. Free proxies are unreliable, slow, and often already flagged by travel sites. They also pose security risks since the proxy operator can intercept your traffic. For a system that needs to run continuously and return accurate data, free proxies are not viable. Budget residential proxy plans starting at $20-30 per month are the minimum for a functional fare alert system. Check frequency depends on how time-sensitive the route is. For travel dates within the next 7 days, check every 15-30 minutes. For travel dates 1 to 4 weeks out, check every 1-2 hours. For travel dates more than a month away, checking every 4 to 6 hours is sufficient. Increase frequency for routes showing high volatility or approaching historically low prices. If an airline detects scraping activity from specific IPs, those IPs will be blocked or serve captchas. With rotating residential proxies, individual IP blocks have minimal impact since you will automatically rotate to new IPs. If an airline implements more aggressive measures like fingerprint-based blocking, you may need to adjust your browser configuration, reduce check frequency, or switch to a different data source for that airline. Use OTAs like Expedia and Google Flights as your primary data source because a single search returns fares from multiple airlines. Supplement with direct airline scraping for carriers that restrict OTA distribution like Southwest or for accessing fare class details that OTAs do not display. This hybrid approach maximizes coverage while minimizing total request volume. Vizhu tries in everything on building a fare alert system with rotating proxies. Check out our other guides at dataresearchtools.com for more. Until next time.